Good day, students of Sleek Angels International School. I hope you're doing very well, and I welcome you all to another section of our online classes. Today we have an important topic that is a continuation of the topic we have learned before. If you have not seen that topic, you should go to our YouTube channel on Sleek Angels International School and see the video so that you can understand this section of the topic. I want to commend all those that have done their assignments and sent to my email and WhatsApp number. I am very pleased with what you're doing so far. The topic here is straight line. Like I said earlier, it is a continuation of the topic that we had done before. In that video, we treated gradient of straight lines, we treated the equations of straight lines, and so many other things that we talked about in the video. In today's class, we will be looking at straight lines, and our lesson objectives is to determine the distance between 2 points, to determine the midpoint of a line segment, and to determine the coordinates of a line segment in a given ratio. By the end of this class, students should be able to determine the distance between 2 points, determine the midpoint of a line segment, and determine the coordinates of a line segment in a given ratio. So like the lesson objective says, the first one we have to deal with is the distance between 2 points. The distance between 2 points on our Cartesian graph. If you look closely, we have a replica of a graph where we have the y coordinates and the x coordinates. We are interested in knowing the length of P and Q, or the distance between P and Q. Some textbooks usually write it as distance between P and Q. Some write it as length of PQ. So if you notice, P will have coordinates x1, and Q will also have coordinates x2. So from this point, we can see that the distance between these points on the horizontal axis is x2 minus x1. That's the distance between this point and this point. Then similarly, P will have coordinates y1, and Q will have coordinates y2. So the distance between P and Q vertically is y2 minus y1. So if you notice, we have been able to form a right-angled triangle here. We have been able to form a right-angled triangle here. If you notice, P, Q, and this point form a right-angled triangle. So remember, our aim is to find a formula that will help us get the distance between P and Q. So I want to derive that formula. And from what we have done, it is obvious that the length of P and Q is connected to the vertical distance and the horizontal distance by Pythagoras theorem. So by Pythagoras theorem, PQ squared is equal to the square of the length of the vertical axis, which is y2 minus y1 squared, plus the square of the length of the horizontal axis, which is x2 minus x1 squared. So with this, I have been able to get the relationship between PQ and the length of the axis, horizontal and vertical. So if I make PQ the subject of the formula, it will be square root of y2 minus y1 squared plus x2 minus x1 squared. This is the required formula for finding the distance between 2 points. This is the required formula we use in finding the distance between 2 points. So we don't always need to draw a graph when we are asked to find the distance between 2 points. We don't always have to plot a graph if we are told to find the distance between 2 pairs of points. What we need to do is to use this formula and get the distance or the length of those points that are given. We have an example here on the board, and it says find the distance between the pairs of points. Find the distance between the pairs of points. This is a very simple one, and like I said earlier, we don't have to plot a graph for us to find the distance between these pairs of points. We just need to apply the formula that we have derived to get the distance. And remember, some textbooks will write this as find the length between points A and B, or find the length of AB given the coordinates as 5 minus 8, minus 4, and minus 2. But we have it here as find the distance between the pairs of points. A is 5 and minus 8, and B is minus 4 and minus 2. Most times, you will be asked to leave your answer in solid forms. So in situations like this, we are going to be leaving our answer in solid form because mostly we don't get perfect values. We just don't get values that will have perfect square roots. So in case you see a question around straight line, it is best you leave your answer in solid form. So I am going to use the formula that I have derived here to find the distance between points A and point B. Remember, every point, every coordinate will have an x and y axis. So each time you see a point, look out for two numbers. The first is usually the x coordinate, and the second is the y coordinate. So just like A has 5 and minus 8, B has minus 4 and minus 2. So 5 is the x1 and minus 8 is the y1, while B, minus 4 is the x2 and minus 2 is the y2. So if I use this formula which says PQ is equal to square root of y2 minus y1 square plus x2 minus x1 all square. Remember, this is PQ because we were told to find the distance between P and Q. But in the situation we have in our example, we are dealing with AB. So in place of PQ, we are going to write AB. So you use the letters of the points that are given to you. If letters are not given, just use the letter D to denote distance. But now that we have points A and B, we're going to find the distance as AB is equal to square root of y2 minus y1 all square plus x2 minus x1 all square. So to help our understanding, we have to label 5 as our x1 and minus 8 as our y1, and then we label minus 4 as our x2 and minus 2 as our y2. So we just impute those values here. I have AB to be equal to square root of y2 from here is minus 2 minus y1 is minus 8, so it has its own minus sign, so I put it in a separate bracket to separate the minus signs. Mathematics students should understand that when a letter has a minus sign, you enclose in a separate bracket to separate the existing minus sign. Then I have plus x2 from this is minus 4 minus x1 is 5. So I don't need to put another bracket because x1 was just a positive 5. So it continues. AB is square root of minus 2 plus 8 squared, knowing that minus times minus is a plus, plus minus 4 and minus 5 gives minus 9 squared. So it's a continuation of the process. Minus 2 plus 8 is 6, while minus 9 squared is still there, and AB is 36 plus 81, knowing that 6 squared means 6 times 6, which is 36, and minus 9 means minus 9 times minus 9, which is 81. So AB is equal to 711. So we have 117 units. So we're leaving the answer in root form because 117 is not a perfect square. So the distance between the points A and B has been found to be root 117 units. Root 117 units. You can see that we did not need to plot a graph before we found the length of line A and B in our last example. We have a very similar scenario, which is part of our lesson objective, which is to determine the midpoint of a line segment. In other words, to determine the coordinates of the midpoint of a line segment. So we have our improvised graph here, which has a line segment of P and Q. You can agree with me that there will certainly be a point here which is the midpoint of P and Q. That midpoint, let's label as Y, will have its coordinates in the x-axis and its coordinates in the y-axis. We know that the coordinate of P here is x1 and that of Q on the x-axis is x2, while the coordinate of P on the y-axis here is y1 and the coordinates of Q on the y-axis here is y2. So certainly Y will have a coordinate that is halfway between x1 and x2. So Y coordinates will be in between x1 and x2, while y coordinates on the y-axis will also be in between y2 and y1. So since we have agreed that it's going to be in between, the coordinates of y will be x1 plus x2 all over 2 and y1 plus y2 all over 2. So this is the formula used in finding the coordinates of the midpoint of any line segment. Since we know that y coordinate will be in between x1 and x2, if we add those and divide by 2, you will get the coordinates of y. And then if you also add the y1 and y2 and divide by 2, you will also get the y coordinates of y. So we're going to use this relation, or this formula, or the relationship rather, to get the coordinates of the midpoints of the pairs of points that we have in our example here. And this example says, find the coordinates of the midpoints joining the pairs of points where we have C as 4 and 4 and D as 2 and minus 6. So if we were to plot this graph and locate the midpoints, that point will have a coordinate. But like I said earlier, we don't always need to plot a graph in order to get the coordinates of the midpoint. So all we need to do is to use the relationship or the formula that we have here, and we will be able to get the coordinates of the midpoint. So we're going to take a letter to denote the points of the midpoint of C and D. We're going to use a letter to denote the position of the midpoint of C and D. Like we used Y here to denote the midpoint of P and Q. So you can use any letter of your choice, M, X, Y, or any one you like. So we say let M be the position of the midpoint of C and D. Then using the formula, M becomes x1 plus x2 all over 2, comma, y1 plus y2 all over 2. So we're still using the relationship that we had here for x and y for us to be able to get the coordinates of the midpoint. So M is, this is our x1, this is our y1, this is our x2, and this is our y2. So from here, x1 is 4 plus, here x2 is 2. So we have 4 over 2, 4 plus 2 all over 2, comma, y1 here again is 4 plus y2 here is a minus 6. So I have to include that in a separate bracket to differentiate the signs. So n is 4 plus 2 is 6 over 2, and 4 minus 6 is minus 2 over 2. Knowing that 4 plus times minus is minus, and 4 minus 6 divided by 4 minus 6 will give us minus 2. And when I do this division, 6 divided by 2 is 3, and minus 2 divided by 2 is minus 1. So the coordinates of the midpoints of C and D, which had coordinates 4, 4, and 2 minus 6, is 3 and minus 1. I bet you if you plot the graph and locate the midpoints and find the coordinates of those or that midpoint, you will get a 3 and a minus 1. In our third and final objective for the day, we will be learning to find the coordinates of a line segment in a given ratio. In other words, we'll be learning to find the coordinates of a point that divides a line in a given ratio. Just like we have our line P and Q, in our last session, we learned to find the coordinates of the midpoint. But in this session, we will be learning to find the coordinates of a point which divides the line in a given ratio. Let's say m is to n. Just like we have in our primary school mathematics, where they will ask you to divide a given number of oranges in a ratio of, say, 4:5. That is how it is in this session. If, for example, we have a line which is P and Q, and let's say it is 10 centimeters long, and you are told to divide that line in a ratio, say m is to n. When you're done with the division, this point will have a coordinate, just like the midpoint had a coordinate. So the P had its coordinate as x1, and the Q had its coordinate as x2. The P also had a coordinate of y1, and the Q had a coordinate of y2. So if we are told to divide this line PQ in the ratio of m is to n, then the coordinate of that point, let's say C, will be mx2 plus nx1 all over m plus n. That will be the coordinates of the x-axis of that point C. Similarly, the y-coordinates will be given by my2 plus ny1 all over m plus n. So when we are told to find the coordinates of any point that is divided by a given ratio, then we apply this simple formula. We take that, the formula is simple. It is the coordinate C is given as mx2 plus nx1 all over m plus n, and my2 plus ny1 all over m plus n. M and n represents the given ratio. x1 and x2 are the coordinates of the original position of the point. So we're going to use this formula to solve the example we have on the board. And the example says that R divides the line PQ, where the coordinates of P and Q are 5 and 2 and 3 and 7 respectively, in the ratio 4 is to 3. Find the coordinates of R. Find that coordinates of the point R that divides line PQ in the ratio of 4 is to 3. In our formula we used C, but in this case the coordinates or the letter they used for the points they are looking for is R. So in place of C, we will be writing R. So R will be written as mx2 plus nx1 all over m plus n, comma, my2 plus ny1 all over m plus n. This is the required formula for getting the coordinates of R. And you can agree with me that m and n represents the ratio that was given as 4 is to 3. So m is 4 while n is 3. And the first coordinates that was given here is 5 and 2. So our x1 is 5 and our y1 is 2. And the second coordinate is 3 and 7. It means that our x2 is 3 and our y2 is 7. So if we substitute those into the formula we have, n, which is 4, will multiply x2, which is 3, plus n, which is 3, will multiply x1, which is 5, all over 4 plus 3. Similarly, on the y-axis, m, which is still 4, will multiply y2, which was given to us as 7, plus n, which is 3, will multiply y1, which is given to us as 2, all over 4 plus 3. Then we have the common bracket. And R is 4 times 3 is 12, plus 3 times 5 is 15. We followed BODMAS where multiplication came first. 4 plus 7, 4 plus 3 is 7, comma, 4 times 7 on this part is 28, plus 3 times 2 is 6, all over 7. Then the coordinate of R will be 17 over 27 rather over 7, comma 34 over 7. So we have been able to get the coordinates of R if that line PQ was divided in the ratio of 4:3. We did not have to draw a graph in order to find these coordinates. So the first one we did was to determine the distance between 2 points. We established the formula for it. The second is to determine the midpoint of a line segment, and we established the formula for it as well. And finally, we just learned to determine the coordinates of a line segment when it is divided in a given ratio using this formula. Please, I hope you will be able to apply this formula when you see questions around them. I will be writing your assignments and your research work for you to use the formula that we have just learned today to solve them. When you're done, please screenshot and send to the email address and the WhatsApp number that will be provided for you. Thank you very much. The assignment is written on the board. The first one says, find the length of the line joining the points D -1, -1 and E 7 minus 3. The second one is find the coordinates of the midpoints joining the pairs of points A 3 minus 6 and 5 8, B 3P Q and Q 3P. And the final one is find the coordinates of the points which divide the line joining the points 5 minus 4 and -1 3 in the ratio of 3:1. Find the coordinates of the points which divide the line joining the points 5 minus 4 and -1 3 in the ratio of 3:1. When you're done, please screenshot and submit to anekevictor16@yahoo.com or 07039371313.